In this video, we're going to introduce a few applications of derivative review problems of different kinds, and we're just going to introduce the questions in this video. I'm going to go through them, and hopefully you can pause the screen and write these down and work them yourself. So the idea is you should work these on yourself without using any notes, and then come back to the next video or two where I will go through the solutions to them. So number one, a highway patrol officer's radar unit is parked behind a billboard 200 feet from a long straight stretch of Interstate 40. Down the highway 270 feet from the point on the highway closest to the officer is an emergency call box. The officer points the radar gun at the cars actually, but just by the call box, and measures the speed of the traffic passing by the box. Actually, the radar unit measures how fast the distance between the radar unit and the traffic is increasing at the time the automobile passes the call box. If the posted speed limit is 75 miles per hour, what is the maximum speed measured by the radar gun, which would correspond to a legal speed of traffic? Number two, an economist is interested in how the price of a certain commodity affects its sales. Suppose that at a price of P dollars, a quantity Q of the item is of the commodity is sold. Okay. Explain in economic terms what is the meaning of the statements Q of 19 equals 482,500, and be sure to use appropriate units. B, explain in economic terms the meaning of the statement Q prime of 19 equals negative 5,200, being sure to use appropriate units, and explain why that should be a negative in economic terms. Estimate Q18 and Q20 using this information. Part 3, the daily number S of cans of paint that suppliers are willing to produce at P dollars each is given by S of P equals 5,830 times parentheses E to the 0.36 P, and then minus 9.75 close parentheses, and then minus 87. That's a supply curve. A, what is the lowest price at which the company will supply any paint? What is the marginal supply function? What's the sign of the marginal supply function, and how do you know from economic terms? And I guess does the algebra or calculus bear that out? And D, if the current price per can is $9.29, find and interpret the marginal supply for cans of paint. Number 4, a man is building a storage building in the shape of a right circular cylinder. The cost of the concrete floor is $5 per square foot. Cost of the walls is $3 per square foot, and the cost of the roof is also $3 per square foot. The volume is to be 4,876 cubic feet. What dimensions will minimize the cost of the building? Number 5, a 350-room hotel is filled when the room rate is $54 per day. For each $1 increase in the rate, 5 fewer rooms are rented. Find the room rate that maximizes daily revenue. At this rate, how many vacant rooms will there be, and what is the maximum revenue? Number 6, the number of people N of T in a community who are reached by a particular roomer at time T days after the roomer starts is given by the equation N of T equals A over 1 plus B e to the RT. What are the significance of the parameters A, B, and R? Give some graphical sketches to support your conclusions, and what function represents the rate at which the rumor is spreading T days after it is started. So analyze this family of functions. And remember, it does have a physical context. Number 7, a farmer has 670 meters of fencing with which to enclose a rectangular pen adjacent to a long existing wall. He will use the wall for one side of the pen and the available fencing for the remaining 3 sides. What is the maximum area that can be enclosed in this way? 8. The height of a ball, y, that is tossed straight up is given by the following formula. y equals negative 16t squared plus 35t plus 15, where the height is measured in feet and t is the time since the release measured in seconds. Negative represents the downward direction. Include all your units on your answers. A, at what height is the ball released or thrown? B, what is the height of the ball 1 second after release? C, the velocity is the instantaneous rate of change in the height with respect to time. What is the velocity formula as a function of time? D, at what speed was the ball thrown? E, what is the velocity of the ball 1 second after release? Include units and interpret the direction of the ball at that time. F, when is the ball at maximum height and what is the maximum height? For G. The acceleration of the ball is the instantaneous rate of change in the velocity. What is the acceleration as a function of time? Include appropriate units. And I, when does the ball reach the ground? Problem 9, f of x equals the natural logarithm of parentheses x cubed plus 1 with x greater than negative 1. Okay. Actually, I didn't have to say x is greater than negative 1. That's implied by the function there. A, describe the behavior of the function as x approaches infinity and as x approaches negative 1 from the right side. For what values of x is the function increasing and for what values is it decreasing? This is at local extrema. For what values of x is the graph of the function concave up and where is it concave down, and find any inflection points. So in other words, basically you just want to completely analyze this this function. Okay. Number 10. A swimming pool is 50 feet long and 20 feet wide. Its depth varies uniformly from 2 feet at the shallow end to 12 feet at the deep end. Suppose that the pool is being filled at a rate of 1,000 gallons per minute. At what rate is the depth of the water at the deep end increasing when the depth is 6 feet? And you may need this conversion factor that 1 gallon is approximately 0.1337 cubic feet. Number 11, an airplane flying east at 400 miles per hour goes over a certain town at 11:30 a.m. and a second plane flying northeast, that is, let's be specific, north 45 degrees east at 500 miles per hour goes over the same town at noon. How fast are they separating at 1 o'clock p.m.? And then finally, number 12, we've got 3 limits to compute. The limit is x approaches 0 from the right side of sine of 3x over 4x cubed. The limit is x approaches infinity of natural logarithm of 4x squared over 15x. And the limit is x approaches 0 from the right side of x to the power sine of x. So once again, hopefully you jotted these down, or you can rewind and stop the video on problems you want to work. But work out these on your own and then come back and check them against the provided solutions that we'll provide in the next couple of videos.